area and volume stuff, we should be perfect with these things here. Just be careful. Make sure you're practicing without the calculator. As we look at the problems here, we don't have a calculator on this one. You could tell this is the negative quadratic because the negative's right there. You know, if the negative's in front of the x squared, you're just going to open downward. And this was a little more curvy nature with that picture graph. So I right away labeled it h function, g function, just so I know. So when we're doing area, remember it's just top curve minus the bottom curve. So it's your h graph minus your g graph, and then it's a dx problem when you go top minus bottom. So go left to right, use the x's that take you across that bounded area. Now, first thing I did, I distributed the negative. Then I had a 6 plus 2. Remember looking at the sign in front. 6 plus 2 gave us an 8. Carried that down, and then you integrate it. When you integrate 8, you get 8x. Here, your u is equal to inside that parentheses. Your du is equal to 1, so there is nothing to balance. But if you're like you had a 3x minus 1 in there, then you're going to balance that through with a 1/3, right? But you're integrating like a u squared. You get a u cubed over 3, and then that 2 carries down. And then you can plug your x's back in. There's that part. And here the negative 3 carries down. Remember, when we integrate cosine, you're going to get a sine of that angle, but your du is equal to that weighted angle. Your u is equal to the weighted angle. Your du is equal to pi over 2, which means you balance it with the reciprocal with the 2 over pi. So that becomes a negative 6 over pi, and then you got the sine of pi x over 2. And then you got to plug in the 2 in for all the x's, minus, take the bottom number 0, plug it in for all the x's. So we'll get a 16. 2 minus 1 is just 1, so you're going to get negative 2/3 there. And when you plug in the 2, the 2's cancel out because it's pi over 2 times 2. That's your angle now. The 2's cancel, you get the sine of pi. Sine of pi is over there at 180 degrees. That's the y value, which is 0. That's why I got a 0 right there. And you go minus. Then we got to take the 0 and plug it in. So you get a 0 for that part, but you don't get a 0 for this part. That's negative 1 cubed, which is a negative 1 times a negative. So the minus I already carried down. And then when I got the negative 1 times 2, I got a negative 2/3. So minus negative made that plus a positive 2/3. And when you plug in 0, you get the sine of 0, which is just that y value there, which is equal to 0, right? And then be careful with that part. Just carry everything down. Be careful with your arithmetic. I made that 48 over 3. That was a 16. And then minus the 2/3 minus another 2/3. Get that 44 over 3 right there. All right, now letter B. Let's be careful here. All right, this is a really simple problem. I know when you see that word cross section, some of you kind of freak out a little bit. We're going to be fine. This is like the easiest cross section problem I've ever seen. Now, they didn't give us squares or rectangles or semicircles or anything like that. They told us for each side, each cross section to the perpendicular to the x-axis has an area of that. Now, normally, you got to remember what we always do. All right. We always, when we do cross-sectional volume, we always integrate the area of the cross-section shape. They were gracious to just flat out give us that area. They didn't give us the s like the side of the square. We didn't have to find the s, which is the side of the square, and then do the area of that s squared, or the area of a triangle or a semicircle or something like that. Remember, cross sections, you integrate the area of your cross-section shape. Since they gave us the area, that's what we're integrating. That's what you do for cross sections. You integrate the area of your cross section shape, which they flat out gave us. That's an easy LN because it's just 1 over a single letter right there. Now be careful, because if it's a 1 over like 4x plus 3, then you're going to balance that 4 with the 1/4 there. So be careful with that. Technically, you got the absolute value bars there. So if you ever like were to plug in and get an ln of a negative number, don't say that's undefined. You're supposed to do the ln of the positive number, because technically those absolute value bars are there. So just plug in the 2, plug in the 0, and you're allowed to leave your answer like that. Perfectly fine. If you want to make it that, you can, but you're allowed to leave it exactly like the ln of 5 minus ln of 3, 100% there. All right, and then the letter C is just your disk method. Horizontal line y equals 6. So horizontal, going about that axis, right? One of our 4 big scenarios. So we're going to like draw a rectangle perpendicular in there. Going to be the disk method. Remember, capital R is a distance from your axis of revolution to your farther edge. Anytime we come from that axis down, it's always been that number minus y. So we're going to go 6 minus y, but then that's to your farther edge. That y is your g graph, and you don't have to write down the whole entire function. You're allowed to put just 6 minus g. And then the little r is distance from your axis of revolution to your closer edge. And again, you're still coming from that axis down. That's one of our 4 big scenarios. When you come from that axis down, it's still that number minus y, but that's your closer edge. That's your h function. So you can go 6 minus h. So then this Gratefully, no calculator, but doesn't matter. They just said write, but do not evaluate. We just got to set this thing up like we're used to. So pi guy out in front, capital R squared minus a little r squared. That whole thing, you know, you got your dx and you got your numbers attached. It's a dx problem, so go left to right, use the x's that take you across that bounded area right there. Jolly Ranchers.